The watt 1 kg m2s-3 A. Equivalently, 1 joule per second. It is used to quantify the rate of energy transfer. The watt is named after James Watt, an 18th-century Scottish inventor. When an object's velocity is held constant at 1 meter per second against a constant opposing force of 1 Newton, the rate at which work is done is 1 watt. In terms of electromagnetism, 1 watt is the rate at which electrical work is performed when a current of 1 ampere. 2 additional unit conversions for watt can be found using the above equation and Ohm's law, where omega, omega, is the SI-derived unit of electrical resistance. The watt is named after the Scottish inventor James Watt. This unit name was proposed initially by C. William Siemens in August 1882 in his President's address to the 52nd Congress of the British Association for the Advancement of Science, noting that units in the practical system of units were named after leading physicists. Siemens proposed that watt might be an appropriate name for a unit of power. Siemens defined the unit consistently within the then existing system of practical units as the power conveyed by a current of an ampere through the difference of potential of a volt. In October 1908, at the International Conference on Electric Units and Standards in London, so-called international definitions were established for practical electrical units. Siemens' definition was adopted as the international watt. The watt was defined as equal to 107 units of power in the practical system of units. The international units were dominant from 1909 until 1948. After the 9th General Conference on Weights and Measures in 1948, the international watt was redefined from practical units to absolute units. Concretely, this meant that 1 watt was now defined as the quantity of energy transferred in a unit of time, namely 1 J/s. In this new definition, 1 inch absolute watt equals 1.00019 inches international watts. Texts written before 1948 are likely to be using the international watt, which implies caution when comparing numerical values from this period with the post-1948 watt. In 1960, the 11th General Conference on Weights and Measures adopted the absolute watt into the international system of units as the unit of power. The octowatt is equal to 1 septillionth of a watt. The zeptowatt is equal to 1 sextillionth of a watt. The attowatt is equal to 1 quintillionth of a watt. The sound intensity in water corresponding to the international standard reference sound pressure of 1 micropascal is approximately 0.65 AU per square meter. The femtowatt, this is 0.2739 microvolt across a 75 ohm load, or 0.5477 microvolt across a 300 ohm load. The specification takes into account the RF input impedance of the tuner. The picowatt of a watt. Technologically important powers that are measured in picowatts are typically used in reference to radio and radar receivers, acoustics, and in the science of radio astronomy. 1 picowatt is the international standard reference value of sound power when this quantity is expressed as a level in decibels. The nanowatt is equal to 1 billionth of a watt. Important powers that are measured in nanowatts are also typically used in reference to radio and radar receivers. The microwatt is equal to 1 millionth of a watt. Important powers that are measured in microwatts are typically stated in medical instrumentation systems such as the EEG and the ECG. In a wide variety of scientific and engineering instruments, and also in reference to radio and radar receivers. Compact solar cells for devices such as calculators and watches are typically measured in microwatts. The milliwatt is equal to 1,000th of a watt. A typical laser pointer outputs about 5 milliwatts of light power, whereas a typical hearing aid for people uses less than 1 milliwatt. Audio signals and other electronic signal levels are often measured in dBm. Reference to 1 milliwatt. The kilowatt is equal to 1000 watts. This unit is typically used to express the output power of engines and the power of electric motors, tools, machines, and heaters. It is also a common unit used to express the electromagnetic power output of broadcast radio and Television transmitters. 1 kilowatt is approximately equal to 1.34 horsepower. A small electric heater with one heating element can use 1.0 kilowatt. The average electric power consumption of a household in the United States is about 1 kilowatt. A surface area of 1 square meter on Earth receives typically about 1 kilowatt of sunlight from the sun. The megawatt is equal to 1 million watts. Many events or machines produce or sustain the conversion of energy on this scale, including large electric motors, large warships such as aircraft carriers, cruisers, and submarines, large server farms or data centers, and some scientific research equipment, such as supercolliders, and the output pulses of very large lasers. A large residential or commercial